So, welcome students. This class number is MA 526, that is fuzzy logic and set theory. Fuzzy logic and set theory. So, I hope you know this logic and set theory. What is logic? Logic theory and set theory you already know. Here this word fuzzy is added with logic and set theory. Okay? Now, before going into the detail of this subject, let us see why we need this subject and what is this subject and what we will do. Okay? Why, what and how. So, as you know, this fuzzy actually is a branch of mathematics. In mathematics, fuzzy is a subject, and this fuzzy actually comes under your AI, that is, what is that? Artificial intelligence, or sometimes we call it as soft computing methods. Now, in AI we have different areas. Fuzzy is one of them. There we have ANN, that means artificial neural network, GA, that is genetic algorithm. We have then different optimization techniques. Okay, so the GA is one of them. Here fuzzy. Okay, then SVM, that means support vector machines. So there are plenty of other areas which comes under this AI, that is artificial intelligence or soft computing. Okay, why we call these techniques as soft computing? Because we know what is hard computing. So remember, these are under AI, or actually in total this comes under all the mathematics. So what is then soft computing? We have hard computing also, that you know. What is the difference between them? Hard computing and soft computing. So I hope that you have done labs and etc. using C, MATLAB or C++, BASIC, etc., etc. Okay, those are actually called hard computing. Okay, because if you want to write any program for any problem, suppose you want to solve differential equation, you want to solve eigenvalue problem, okay, you want to solve system of linear equations, all non-linear equations, then you very well you can write in C, C++, MATLAB, BASIC, or any high level programming language you can use. That is called hard level, hard computing, because there you are writing all the instructions one by one. Okay. In this soft computing, here actually we do not have those instructions one by one, but we have to use some example problems. Okay. Suppose if soft computing also comes ANN. Okay. Here this ANN, although this is not in your course, but we can use this ANN, ANN plus fuzzy, that is called hybrid methods. So if time permits, we will do all those things, but ANN, there actually the training is done by examples. Means if I want to solve any differential equation or eigenvalue problem, we will not write the instructions that you know, different methods for eigenvalue problems or system of equations or something. So there we will use different examples and train that model, and then you will use for new data you can get the answer. Okay, so this we will see later. So with this, now here as I told that why this fuzzy, from here you got, because you know what is set theory, set you know. Okay. Suppose I say that a person Ram is tall. Okay. Ram is tall. So what do you mean by that tall? How you define that tall? I can define it that okay, above 6 feet is tall, but somebody can define no, it is 5.5 feet. If it is above that, then it is tall. Okay. So that means tall means for your this set theory, that is crisp set theory that you know till now, you have the fixed value. Okay. So if I say that X is a set having X such that X is equal to tall, here you have to give some number. Some number you have to define depending upon your means convenience. Okay, I can define here, suppose Chinese or Japanese or whatever, in any country where short heights are there are also long heights. Okay, anyway, so this tall is user oriented. So if I define here suppose 5 feet, so you have all the members, all the man or woman as tall. Okay, now somebody can define 6 feet. So you are seeing that if you are defined exactly, then what you are doing till now it was okay, but in practical sense it is not possible. Suppose I tell what is the weather today, one may say that this is hot, I can say this is hot. Okay, somebody is having suppose fever or something, she or he will say it is cold. Do you have any other answer? You do not have till now any other answer. You have either hot or cold or white. That means if I designate this hot as 1 and cold as 0, that means whatever answer you are giving, those are binary, means either yes or no. If you say your yes is 1, no is 0. That means whatever set theory you have read till now, that is a binary system. Understanding? 1 or 0. Okay? So that is why, but I may say no, this is not hot, this is less hot. Okay? So very hot, less hot, hot, average. So how many answers you may have actually? Again it is user defined. So that is actually your fuzziness or uncertainty. You are understanding? Okay? Similarly cold, hot I can define, okay, if more than 35 degrees centigrade this is hot. Okay? But you may have the range from 30 to 45 maybe hot. Okay? Similarly cold also. So in this way I can have your set as a range of values, and if you can handle that, so that is practically possible. Okay? So those things will be done. So this is for these examples. Okay? Similarly, if I suppose I want to measure this, you have read in physics that we have different error when we are measuring. So if I can have suppose 3 centimeter, or I can say okay this is 3 centimeter or 2 centimeter. Okay? So if I say 2 centimeter, so somebody can say no this is 2.1 centimeter, or somebody no this is 1.99. So you are seeing the various answers. So you have sets of answers for this length. So that means any experiment, anything you are doing, there are errors. Okay? So those errors I can handle by this fuzziness. Okay? So that is why it is very important subject, whatever subject you are reading in mathematics or in any other subjects. Suppose in differential equation, eigenvalue problem, those differential equations are coming from where? Those are coming from some physical problems, whether if you are doing fluid dynamics or solid dynamics or any problem you can take. Okay? So those are coming from some physical problems. If it is coming from some physical problems, then your physical problems will have some property. Those are coming into the differential equations. Okay? So those are coming from the experiment. So if you are doing the experiment, then again you may not get the exact value. So in actual sense, you should not, although people are doing, you should not use the exact methods. This means crisp one. It will be better to use uncertainty there, means then the problem will be complicated, but you will get the result in actual sense. Okay? So essence of uncertainty will be there. So now this was set theory. Now if you see logic also we have read sometime. Okay? But fuzzy logic. So one example for fuzzy logic that you already know, that is washing machine. In every household they are using washing machine, automatic washing machine. There you have fuzzy controller, fuzzy logic is there. Okay? In airplane, fuzzy logic is there, fuzzy controller. So those are logic, means how to move, how to go right, left, etc. In washing machine, after hitting this or how much dirty is there, accordingly it automatically sets. How? Using fuzzy, because there you cannot set one line exactly. Okay? So, you may have uncertainty there, so those things can be handled. Okay? This was logic. So, that is why and what you have understood, at least why we need and what is this. Okay? Now comes how. How will be in this course, means we will slowly do the how we will solve the problems, or how this set theory will be extended to fuzzy set theory, etc., etc. So, before that you take first crispness and impreciseness and imprecise. I have already told that this crispness is that when you know the value of the variable or parameters as exactly, then it is crisp. Okay? And impreciseness, imprecise means you have error in your measurement. That means your variables are not exact. Okay? So, this is crispness versus impreciseness. Understood? Now comes uncertainty and vagueness. Uncertainty and vagueness. So, if I write I will come back soon, this is one statement. Next statement is I will come back within 1 minute. This is another statement. Third sentence is I will come back within 1 minute from 2 p.m. See, these are similar sentences or not? Okay? I will come back soon means what you understand? It is vague. When? I will come back soon. I do not know when. Soon means it may be 1 hour, 2 hour, okay? Or maybe within 2 minutes. So, this is your vague. Okay? I will come back within 1 minute. That means your variation of this uncertainty is 1 minute. It may be 0 minute, just I can come within maybe 0.1 minute, 0.2 minute. So, you have the some boundary, but that is also not exact boundary. You have the limit from 0 to 1, although 0 minute to 1 minute, but in between also you have different answers, na? So, that is, it is fuzzy. Okay? Now, I will come back with, but 1 minute from when? That is a question. From when? I will come back so within 1 minute from 2 p.m. What is that? That is probability theory. There comes the probability. So, there is a distinction, because we have all read probability theory, there is a distinction, that means from probability and fuzzy. So, I will show you after discuss what is the difference between fuzziness and probability. Okay? So, now, so that means uncertainty and vagueness. So, actually in fuzzy set theory or fuzzy this logic or fuzzy set, the boundary is not crisp, boundary is vague. Okay? So, you will see when I will give some example that here your these possibilities are also different depending upon from some lower value to upper value, suppose 0 to 1 here. Okay? So, one thing is that, and the means the boundary also can overlap, because if you remember that example of hot and cold, suppose hot. So, I have different answers, very hot, hot, less hot, average hot. So, that means if you define this hotness, suppose hot I define means very high, very hot, I can define from maybe 50 to 80. Okay? Now, if I define less hot means 50 also maybe I can define less hot. So, there is a overlapping or not? Average hot and hot. So, I have overlap or not? I cannot fix the boundary, na? So, this is the hot or this is the very hot, I cannot define. Again it is user oriented, means I can define, okay, I can feel hot maybe 30 to 35. You can have, okay, no, it is 30 to 37. That is one question. Another question, I can also have 30 to 35, then maybe very hot from 33 to 37. You are understanding? So, there is overlapping, na? So, exactly the boundary is not defined. Okay. So, that is again uncertainty and vagueness. So, in fuzzy set will be actually vagueness, but vagueness may not be fuzzy. Vagueness may not be fuzzy, but fuzzy will be vagueness, vague. Okay? Understood? So, that means for crisp set theory, or actually you called it set theory, just set theory. I am using crisp set theory because we have fuzzy set theory. Okay? So, that is why I am using this word crisp set theory. Okay? Till now you have done set theory. So, in crisp set theory, how you define a set? If I say A is a set, then it is a collection of well defined objects. No, collection of well defined objects. So, little bit I am just revising or introducing you about this set theory, so that I can extend this to fuzzy. Okay? Collection of well defined objects. Okay? Now, suppose X is an element of A. Suppose I take a set A, this is you know all these things, X is universal set, suppose A is a set here and X is an element that you know, 10 class. Okay? So, X is an element in A which is well defined, or maybe x1, x2, xn if it is n dimensional Euclidean space. Okay? So, X belongs to A which is in universal set X, X. Now, we know that if it is a set theory, crisp set theory, so what we write? X belongs to A, or maybe X is outside, then X does not belongs to A. If X is here, then X does not belongs to A. So, what about the characteristic function then? Characteristic function. If I define this characteristic function for this set theory for set A, so I can write this chi A x is equal to 1 if and only if x belongs to A, and 0 if and only if x does not belongs to A. This is your definition, straight away 2 answers. If x belongs to A, it is 1. If x does not belongs to A, it is 0. Only 2 answers. So, the mapping is what? This mapping chi A, this is x to 0 1 set, remember 0 1 set whose elements are only 0 and 1. Okay. Now, if you think about the, I will define exactly afterwards, but if you see the introduction that we have given for the fuzzy set, if you see now, if you have understood, now this mapping should be there in fuzzy, what will be that? X should be mapping from, this chi actually that is written as mu, we will write after that, chi A actually will be x to set 0 1, okay, including 0 and 1, and there are infinite number of points between 0 and 1, because you have different possibilities, okay, 0.1, 0.2, 0.9, okay. You have the least value as 0, upper value. So, see the generalization of the set theory. So, it is very much essential and very much important for practical applications, and that too for your mathematics, means any branch of mathematics, because we have not only fuzzy set, in fuzzy sets we have fuzzy topology, we have fuzzy analysis, we have fuzzy group theory. Okay. Okay, so, you have fuzzy linear algebra, nowadays fuzzy Lie algebra is also there. Okay. So, everything with fuzzy they are all research are going on. So, now this, so little bit about more about this set theory, let us see what are the things you already know. So, remember this characteristic function, okay, chi x which is a function from x to 0 1, okay. Now, relation between sets, those are very simple thing, but what are the relations that you know? First is that already you know, very simple, if A subset of B, B subset of A, and you I hope you know what is A subset of B. Okay? So, A subset of B subset of A, then we write A is equal to B, okay, or not? Similarly, we have some other A subset of B, and when we will have A proper subset of B, when we will have A proper subset of B, some condition will be there, that is A is not equal to B, or not, then A will be the proper subset of B. Okay, there are other relations that you will see later when we will do one by one, okay, all those things. Now, operation on set. Those are what? First is complement. Complement. So, I can write this A complement. What is that A complement? A complement will be what? If X is a universal set, X minus. Similarly, we have A complement is, we can have then any other in terms of complement. You know, empty set phi complement is your X. X complement is phi. I hope you know what is phi, that is empty set having no element. So, we have other operations, those are what? Union, intersection. So, you define A union B, if I write in set builder form, so it will be X such that X belongs to A or X belongs to B. So, these are all very simple, you know from class 8 nowadays. A intersection B, X such that X belongs to A and belongs to B, or not? Now, what is A union X? A intersection X? A union X is X, A intersection X is, there are other properties you know, very simple properties, okay. I am not going into that. A intersection A complement is phi, okay, like those are there, okay. Can I erase this? So, now I will write some properties of crisp set theory, those will be required in our subsequent lectures, okay, in fuzzy. And we will see that how those will be changed when we will use fuzzy set theory, okay. Some of them are not valid in fuzzy sense, okay. So, first is involution. Involution, that is, I have already written A complement is A, okay. Second is commutativity, that you know, A union B is B union A. What does this means? Or A intersection also. What do you mean by this commutativity? Okay, that is mathematically okay, but that means if I first take A and take union B, whatever result you will get, if I take first B and then take union A, same result. So, this is commutative, order is not a matter here, okay, whether you take A union B or B union A, okay. As we have minus plus is commutative, but minus not, okay. Now, third is associativity, that is A union B union C. I can take, if I have 3 sets A, B and C, so whether I take union of the last two and then take the union, or I can take union of the first two and then take union of third, result will be same, okay. So, that is A union B union C. Similarly, your intersection A intersection B intersection C is A intersection B intersection C. Okay, this you all know. Then comes distributive. Distributive. This is for union A union B intersection C. What is that? A union B intersection C. A union B, then intersection A union C. A union B intersection A union C, that is your distributive, as you do A into B plus C, AB plus AC. Okay? So, similar. So, similarly I can change this union and intersection. I can have A intersection B union C is equal to A intersection B and union A intersection C. Am I correct? These properties you will see is not valid in fuzzy set. Okay? This equality will not be there. We will see afterwards. Okay? And that is the problem actually when you will solve the differential equation or integral equation or any hardcore mathematics the procedures you will use, eigenvalue problem. That is the main difficulty. Okay? Then we have idempotency. Idempotency, and this is nothing but A union A is your A and A intersection A is your A. Okay? Sixth is absorption. Absorption is A union A intersection B is what, and A intersection A union B is what? Those are absorption. Tell me, A union A intersection B is A. A intersection A union B A. So, these are, that is why called absorption. Okay? These are okay? Now, we have more 3, 1, 2, 3, 4 properties. So, can I erase? Identity, that is A union null set is equal to A and A intersection X universal set is your A. Now, the important one, that is called De Morgan's law. De Morgan's law. We have in this case A union B complement. Now, I am writing complement like this. Actually, I wrote earlier C. So, anyway, A union B intersection complement is A complement intersection B complement. Okay? Is it okay? Just it will be intersection. If I take now union 1 complement, what will be that? A complement, sorry, same intersection, then it will be A complement union B complement. Okay? Now, we have law of contradiction. Law of contradiction, that is A union, or sorry, A intersection A complement is your phi. A intersection A complement is equal to phi, null set. Again you will see this is different in fuzzy set theory. Okay? And the last one, that is your law of excluded middle. Law of excluded middle. Here it is A union A complement is equal to X. So, these two are very important in fuzzy set theory. law of excluded middle, A union A complement is X. Okay. Now, I hope you also know about convex sets. So, let us discuss little bit, because this is again necessary in your fuzzy set theory, because in fuzzy set there is fuzzy number. So, those will be all convex, etc. So, we will see afterward. Convex set. How you define convex set? A set A is a convex if I take 2 points anywhere here belonging to this set. Suppose I take x and y and join by straight line. If this lies in this set, then we say that convex set. If I say this is the disk, okay, then x y, if I join, it is there. Okay. So, this is your convex set. Similarly, I can have convex set like this. Okay. I can have any 2 points join there, it will be there. So, non-convex set, here also I should. But if you define less than equal to the, with some condition, if you write, then you can say, okay, this circle is okay. Non-convex set, if I write, if I have this set, okay, there may be some points. If you join those, suppose I take a point here and I take a point here, join that, where this x and y lying in that set, but if you join by straight line, here that there are many points which are not in that set. It is non-convex. Okay. Similarly, this annular, if I have this region, again it is non-convex. Okay. So, there are many, this is non-convex. Okay. So, you have physically also you have understood what is convex and non-convex. Now, hope you know what is cardinality. Cardinality of a set is number of elements in the set. Okay. So, cardinality of A is your number of elements in A. If A is finite, then the cardinality will be finite. If this is infinite, then the set will be infinite, or not. If cardinality is infinite, so set is your infinite. Okay. Now, from here I can have also power set. What is power set? What is power set? So, this is the collection of all subsets of, suppose, set A. Okay. So, power set of A is the collection of all subsets of, collection of all subsets of A. Okay. So, if I have A, suppose A, B, C, so power set will be what? How many? That you know that formula, that means. Okay. So, this is actually what? 2 to the power cardinality of A. So, cardinality of A is 3. So, it should be 2 cube, that means 8. So, what are those? Phi, A, B, C, then AB, AC, BC and ABC. So, we have 1, 2, 3, 4, 5, 6, 7, 8. So, we have 8 numbers, 8 subsets. So, these all will be used in fuzzy set also like this. Okay. Now, for a case set, if I have the universal set like this and this side fuzzy set, okay. So, if I have this, so if I have a set A here, okay, and here suppose elements are A, B, C, D, okay. Suppose this is your universal set in fuzzy set also, x usually we define by x bar, that is why I was not taking bar. So, actually fuzzy we define by this x bar. Okay. So, x bar, so do not confuse with that bar, that is complement there. X bar, so here the fuzzy set I told that its boundary is vague. I cannot define like this boundary. So, I can give just like this, you cannot do. Okay, I will give by dot. Okay. And this is your A bar fuzzy set, and suppose we have A here, B here and C here, D here. Okay. Okay, I can have C here, no problem, okay, near to this. So, what about the membership function for these two sets? So, if you remember the definition of membership function for crisp set theory, you have chi A of A is 1, chi A of B is 1. Okay. Similarly, I can write chi A of C is 0. Similarly, chi A of D is 0. Okay. But what about here? Here actually for characteristic function we say here membership function. Okay. In set theory we will do in the next class about all these in detail. So, membership function, because what is the degree of membership? What is the degree of membership that it lies in that set?
Degree is cardinality.
No, not degree is not cardinality. The cardinality is the number of elements. It is not cardinality. Degree means suppose I say C. C is in the boundary. Okay. So, if I start from here, suppose 0 to 1, suppose I take 0. So, slowly if it is near to the center I can say the membership function, or I can say otherwise, this is 1, this is 0. If it is near to the center I can say 1, or if it is outside slowly it is 0, means I can give the C membership as 0.01. Understanding? You can give 0.02 and this AB you can give 1, you can give 0.9, 0.8 depending upon the set and all. Okay. That we will see little later. Okay. But D will be always 0. Understood? Now, if I plot this, yes, I can include D, but here I am giving this as, see, this uncertainty you cannot have from 0 to infinity na, or minus infinity to infinity. You cannot have, suppose I can measure this, I cannot say this is 10 centimeter. Means all these are due to your practical application where error can occur. Error cannot be occurred for 2 meter, even 2 centimeter also. Nowadays very sensitive equipments are also there to measure. Okay. So, you cannot have so much error. Okay. So, it will be with some bound. Okay. So, now if I plot this, see if I say here A, B, C, D and it is 0, this is 1, this point, because in crisp set you have only 2 values, 2 answers, 0 or 1, yes or no, this is yes, this is no. Okay. So, if I take A, so if suppose this is a set or suppose element, so I can have this as A, because this is 1. Similarly, for B I can have this. Okay. But for C and D I have the 0 values only. Understanding? Now, come to here. So, here this is chi A, here I will write now mu A bar, okay, just to distinguish from crisp to fuzzy. Remember, in crisp this is characteristic function we define by chi, here membership function we define by mu. A crisp set if I write A in this class, okay, for our notation, and A bar wherever it is there, that is your fuzzy set. Okay. So, mu A bar, so this mu will vary from 0 to 1 and it can take any value. Okay. Now, you can see for A and B those are 1. So, those are no problem, A, B, C, D. Okay. So, A, B, C, D, so I can have this as A because these are wholly included there. So, B and C, if it is near to the boundary, it may not be 0, it will have some value. So, I can have this C is this, although depends upon how far it is from there or not. So, there is also a uncertainty, but at least you can have the bound of the result. Okay. So, A, B, C, now D is outside very far. So, I can have this D like this 0. So, like that we have several examples for fuzziness. Actually, this is uncertain, and moreover one important thing I forgot, this thing uncertainty I told in the last sentence that I wrote, there I wrote it was probability theory. Okay. Now, you can say that, sir, why we will not use probability theory? Uncertainty can be handled by probability theory, no problem. You have PDF, you have random variable, okay. But if you remember, you should have large values of data, then only you can have the PDF, probability density function, some standard, okay. You have normal distribution or whatever, for that you need, for 5 values you cannot have those distributions. But in general, if I measure some costly experiments, so you cannot do means hundreds of experiments, okay. There you cannot have in general the PDF or the probability function. If it is available, then it is good to use probability or statistics or whatever. But if you have the less number of data and the uncertainty is there, then this is better. And I forgot the great man who has given this theory, that is, I should not forget actually, that is L.A. Jade. He gave this theory in 1965. Okay? So, he is the man who introduced this fuzzy set theory, fuzzy logic all. He is still alive, doing research till date. Okay? So, he is the person gave this idea, okay? And so now it is flourishing all over the world, everybody using slowly. Okay? So, thank you.